Hello, Dr. Casella here, and in this video we'll be talking a little more about recursion. Now recursion is when a function calls itself. When that happens, it is usually very difficult to trace step by step what the function is doing. But I'm going to use this factorial function example to do just that, because it's a little simpler. It's complicated, but relatively speaking, it's simpler, and hopefully you'll be able to get the idea of what's going on. Okay, so I've defined this factorial function that takes the argument n. Well, first of all, let me remind you what factorial does. So if I put in an argument n, factorial calculates 3 times 2 times 1. If I put in a factorial 5, it would be 5 times 4 times 3 times 2 times 1. So basically it just multiplies, it takes an integer number and multiplies it by the next lowest integer, and it keeps doing that until it gets to the number 1, and that's the end. And so here's a definition of the factorial function. 0 factorial is just defined as 1, and then any number after that is defined this way. So if I want to have 1 factorial, it would be 1 times 0 factorial. But 0 factorial is 1, so it's 1 times 1. If I want 2 factorial, it would be 2 times 2 minus 1, which is 1 factorial, so it'd be 2 times 1 factorial. And then I can go here to figure out what 1 factorial is, and you do that until you get to this 0 factorial, which is 1. Okay, so that's the factorial function, and you can see it's recursive by nature. All right, so I've defined this function factorial of n. If n is equal to 0, it returns a 1, because the 0 factorial is 1. Otherwise, it calculates it asks for factorial of n minus 1, all right, which is here, n minus 1 factorial, and then multiplies it by n times recurse, because recurse is defined as factorial of n minus 1. So I get n times n minus 1 factorial, which is the definition of n factorial, and then I return the result. So that's a really simple program, right? But it's complicated what's going on. And I'm able to create this program just straight out, just by looking at the function here of what factorial is. Okay, so now let's take a look at what would actually go on. Well, I'll run this function, okay? So I'll run it. Run module, and you see it prints the number 6. Why? Because I'm telling it to print the factorial of 3. All right, and now we'll go look a little more at factorial of 3 just to see what's going on. So here's my factorial function, and we're feeding in n equals 3. So n equals 3 goes in here. N equals 3 is not 0, so then it's going to go to the else condition. The else condition is, give me factorial of n minus 1. Well, since n is equal to 3, it's going to say factorial of 2. So then if I look at the factorial function here, and I had put in an n equal 2, well, it's not 0, so it's going to do the else condition, which is, hey, give me the factorial of n minus 1. Well, in this case, n is 2, so 2 minus 1 is 1. So it's going to call factorial of 1. So then it goes up here. Factorial of 1. Again, 1 is not 0. So it goes into the else condition and says, okay, give me the factorial of, in this case, n is 1, 1 minus 1, which is 0, factorial of 0. So then it calls the function for factorial of 0. Factorial of 0. If n equals 0, then I'm going to return a 1. Okay, so when it gets to that point, factorial returns a 1. All right, so now that factorial is going to return a 1, and that will be equal to recurse. So 1 is in here, and so then result at this level is going to be equal to n. But remember, when this function was called, n was equal to 1 at that time. So it's going to be 1 times the return value, which is recurse, 1 times 1 So this function now is going to return 1 times 1, 1 times 1. And that's going to get fed into here. Now this function was called when n equals 2. And the factorial of 1 returned 1. So now it's going to be 2 times 1. And so that's going to return 2 times 1. I wrote 1 times 1 because I just carried what was the return here. And then this function is going to return here. And when it was here, it was started off as n equals 3. So then it called factorial of 3 minus 1, which is 2. Well, we know that the factorial, when 2 was recalled, it returned 2 times 1 times 1, which is just 2. So here I just rewrote what was returned here. That was what was returned. And then that gets multiplied by its n, which is 3. And so the final result is 3 times 2 times 1, which is exactly the definition of factorial. And that's why this recursive function works. Okay, that's all. Bye for now.